Welcome back, friends. Today we shall be doing our fourth tutorial in the Aptitude series. If you haven't already checked out our previous videos, we will leave their links in our description as well as in the end screen. Make sure you check them out. Our today's topic is counting the trailing number of zeros, or rather counting zeros, where we will count the number of zeros in the result of any factorial. Suppose you're given an n factorial. It will give us a result. We will count the number of zeros that will be at the end of the result. Suppose your result is 1, 2, 3, 4, 5, 6, 0, 0, 0, 0, 0, 0. So we'll count this using a shortcut trick. Actually, this question is very common in aptitude tests. That is why we have included this in our tutorial. And with this, we will learn real quickly how to find out the trailing number of zeros using a shortcut. So let's start. Now suppose the number that is given is 5000 factorial, and we will have to find the trailing number of zeros in the end result. So 5000 factorial is actually 5000 into 4999 into 4998 into dot 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 3 into 2 into 1. Right? Now it becomes really hard if you try to divide each and every number from here and try to find how many 5s are there, because zeros are always caused by 5s. The presence of 5s causes a 0 in the trailing end. Therefore, we will try to find out how many 5s are present. Now there is a shortcut for it. The shortcut goes, suppose you have a number like n factorial, we will divide that n by 5. Now this will give us a result. Now the result might be in a form like 1.6 or 2.5. We'll always take the integral part only. We'll always take the integral part. And now n by 5 will give us a result. We'll take its integral part and we'll do a comparison. We'll compare whether the integral part is greater than 5 or it is less than 5. If it is greater than 5, then we will divide that integral part by 5 again. This will again give us a result. We'll take the integral part of that and again we'll compare it with 5 and check if it is greater than that. If it is again greater than that, we'll continue this process till we get an integral part which is less than 5. We will continue up to this step. When this becomes true, when this statement becomes true, we'll stop our execution. After stopping our execution, we'll add all the integral parts that we found out. Integral part 1, integral part 2, integral part 3 up to integral part k, which we found out in our last step. We'll add all of these and this will give us the total number of trailing zeros in the end result. So let's try it. So let's start off with 5000. So the number n given here is 5000. We'll divide it by 5. The integral part we get is 1000. Now 1000 is greater than 5. So we'll again divide 1000 by 5. What we get is 200. It is again greater than 5. We'll again divide 200 by 5. We get 40. 40 again is greater than 5. So we'll divide it by 5. We get 8. 8 is greater than 5. So we'll again divide 8 by 5. What we get is 1.6. Now, the way I had said, we will only take the integral part, that is 1. Now 1 is less than 5. We were waiting for this step. So as 1 is less than 5, we stop. And now we'll add all the integral parts that we found out previously. So we'll add 1000, we'll add 200, we'll add 40, we'll add 8, and we'll add 1. We'll add all of these together, and here we get 9, 4, 2, 1. So it's 1249. So these are the number of zeros that will be at the end of 5000 factorial. When you do 5000 factorial, the number of zeros that will be there at the trailing end of the result is going to be 1249 zeros. Okay, let's try it with another example. So suppose the second number that you were given is 155. So n is 155. We divide it by 5. What we get is 31. It is greater than 5. Therefore, we'll divide 31 by 5 again. What we get is 6.2. We'll take the integral part, that is 6. 6 is greater than 5. We'll again divide 6 by 5. We'll get 1.2. We'll again take the integral part, that is 1. 1 is less than 5. So we reached this statement and we stop our execution. We'll add the integral parts we found out. So we'll add 31, we'll add 6, we'll add 1. It gives us 38. So 155 factorial will have a result which will have 38 trailing zeros. Okay, so 155 will have a result which will have 38 trailing zeros. Let's try it for another example. Now suppose our next number is 12025 and we have to find the number of trailing zeros in its factorial. So we'll take 12025, we'll divide it by 5. What we get is we get 2405. Now 2405 is greater than 5. We'll divide 2405 by 5 again. So we'll get 481, which is again greater than 5. Again divided by 5. So we'll have 96 point something, but we'll take the integral part only. So that's 96. So we'll again divide 96 by 5. So we'll get 19 point something, but we'll take the integral part only. So it's going to be 19. 19 is again greater than 5. So I'll do 19 by 5, give me 3. Now 3 here is less than 5. As soon as we reach an integral part which is less than 5, we will stop. Now let's add all the integral parts, that is 2405, 481, 96, 19 and 3. Now on adding, what we get is 6, 12, 12 plus 9 is going to be 21, 21 plus 3 is going to be 24. So we'll have 2 here, 10, 20, 2, 8, 10, 1. So we'll have 3004 trailing zeros at the end of 12025 factorial. So we'll have 3004 trailing zeros at the end of 12025 factorial. So that's it for today, guys. We hope that this will really help you in your upcoming aptitude tests. If you like this video, don't forget to like, share and comment on our videos, and do hit the subscribe button as well as the bell icon to be the first one to view our video. Stay tuned for our coming aptitude videos, and thank you for watching.